We'll start out with a real easy one. We're going to start out with our quadratic. Everybody go ahead and graph for y equals x squared. We take a graphing family, and then we can transform it using transformations. Graph that.
A ver, toque la puedes ver si es cierto así. De volada, a ver si es cierto. ¿Qué tan bebilla tiene? Es un problema. Poco yo. Poco yo. ¿Verdad que si tan bebilla está? ¿Verdad que si tan bebilla está? Traigo 5. Eres mi amigo.
You should already have this graph, a standard parabola.
That's the U, right?
Goes through 0, 0, 1, 1, 2, 4,
And 8, right?
3, 9. 3 squared is 9. 2 times 2 is 4. 1 times 1 is 1. The negatives behave like the positives. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. And you get a standard shaped parabola. You should be really good at drawing this by now. In order to transform this, we do quite a few different things. One of them is that we can translate it to a new location. That's going to re-zero your parabola. It's going to be a standard shape because its leading coefficient is 1. There is a 1 here, even though you don't see it. It's exactly the same shape as the black one, translated to a new location. Where's the new vertex?
35.
35. Put it on 35 and graph the line. Graph the curve. Okay, that's a really good question, and it's really hard to explain. Basically, what they've done is they've put the 5 on the wrong side. This 5 is actually associated with the y. This should have been written like this. Y minus 5 equals x minus 3 squared. What they did was they added the 5 to both sides so that it would be y equals form. In this case, we zero out our x and our y. In this case, we zero out the x, and then the y gives us that value. Whichever way makes more sense to you, these are exactly the same thing. Our vertex is at 3, 5.
Very disrespectful.
Yeah, it is. That's okay. You can get away with it while you're in school. 1, 2, 3, 1, 2, 3, 4, 5. This point is your vertex. From here, you can go to 1 and square it and get 1. You can go to 2 and square it and get 4. And the same thing on the other side. This will give you your standard shape.
I got it right. Yeah. I've been doing my homework.
Now we can also get reflections. If this had been a negative in front of this, then it would be a reflection. A negative 1 here would have given us this parabola that looks exactly the same, just goes down instead of up. Stretches and compressions are a little more difficult. We'll do this one. Let's go with -1/3 x plus 4, quantity squared, minus 2. Relocate this, and what I like to do is actually graph this one and then stretch or compress this one to get this one. So I'm going to graph both of these.
You want to graph both?
Yeah, you need to. Where's the vertex?
-4, -2.
-4, -2 is your vertex in both cases because we moved it in the same ways. The blue one is a standard shape, but it's a negative, so it's going to go down. I want to have it go down so that I can work with this one, because it's also going to go down. It's a reflection. This one has the standard shape, which is 1, 1, 2, -4, and so on.
Which one is that one, the blue one?
The blue one has a -1. This is going to be 9. A standard parabola that has no number in front of it always has that shape. Now the tricky part is to deal with that -1/3. This is a compression. The best way to understand a compression is to go to a value that you kind of know. I happen to know what value this is. This is 9 right here. And I'm going to make it 1/3 as high. I'm going to compress this wall back to 1/3, which is at 3. It's as if I take this wall and compress this thing back. This point, which is right here, goes compressed to directly here. This is an exact set. The vertex is in the same location, and my compression ends up looking like this.
What points are those?
Well, I chose the 9. I chose the ones that were 3 out and 9 down. I chose this one that's 3 and 9 down to compress. I compressed it to 1/3 the size, so I compressed it to 3. This 9 is now 3.
So does it matter what point you pick?
Not really. Now, you can do this kind of just by glancing at it and guessing. Let me show you what I mean. I could have just done this. I could have said, okay, see the blue one? Figure about 1/3 of this distance is right about here. And then take this point and move it straight back. Take this point and move it straight back. And you get the same curve. It's just, how you do it. Let's go ahead and graph your absolute